Okay, today we are going to take a look, Standard 18, Lesson 2, the properties of logarithms. So our essential question, what are the properties of logarithms and how do we use them?
So this is called our change of base formula. Okay, so it's kind of it's a formula. It works for all logs. The first one up here, okay, that one right there, says that you can change any logarithm of any base to any other logarithm of any base to do your calculation. So here I have log base c of a. So I'm going to change my base. Okay, instead of base c, I'm going to use a base b. And you take the log base b of a on top, log base b of c on bottom. And that would give you the exact same answer. So if I was able to calculate, so if I had log, so I'm going to use a 10, so the b would be a 10, or the b is going to be an e. So either one. And again, these will give you the exact same answer. So log base 4, 5. So we will either change it to log 5 over log 4, some like that, or you could do the natural log of 5 over the natural log of 4. Either way, it would give you the exact same answer. All I'm going to have you do at this point is just rewrite it, just so you get used to the change of base, and rewrite the change of base. We're going to use it later. So for here, and I'll ask what to use. So the common logarithm, which is base 10, so just rewrite it using the example we have up there. Rewrite this and rewrite using the natural logs for the next one. Okay, so for the first one, log 8 over log 3. And the way I usually remember is the base is on the bottom. It's down low. So it's got to go to the bottom, so the 3 is on the bottom. The other number is higher than the base, so it goes on top. That's how I remember which number goes on top and bottom. Okay, for this one, it'd be ln 8 over ln 3. Okay, questions?
Another example of the change of base formula. So we have log base 10 of 12. And all we're wanting to do right now is just rewrite it. And so we're going to use first the base 10 formula. Remember, the base can be anything as long as it's the same base when you're using the change of base formula. But typically we use base 10 and base e because later when we want to actually calculate the values, these are the two values that we have on our calculator to help us calculate it. So log base 6 of 12. So 12 is our bigger number. It's above the 6. The 6 is a subscript. So we're going to do the log 12 on top, and then we're going to do a log 6 on bottom. So that's the change of base. Now it's in base 10. So then I can actually calculate these values and divide to figure out what the log base 6 of 12 is. Or we can use our natural log, the base e, which would look natural log of 12 divided by natural log of 6. So again, these will give you the exact same answer. Now, a few other properties. These first two we're going to look at. You won't have any of these on your assignment for today, but we will be using these later when we get to standard 20 and we're wanting to solve equations with logs and exponentials. So this is one of the main properties that allow us to do that. The idea that logs and exponential equations are inverses of each other, so they undo each other. So here I have an exponential, so I have b raised to the log base b of x. And again, since the exponential part and the log part are inverses of each other, it gives us just the argument x as our answer. So an example with some numbers, if I have 5 raised to the power of log base 512, since the base of the log is the same as the base of the exponential part, the answer would be 12. Works the same way the other way around. If you have log base b of a power, b to the x, as long as the bases are the same, then your answer would just be the x part. So looking at it with some numbers, if I have log base 5 of 5 to the third power, your answer would just be 3. Now, these next three are expanding or condensing. Usually if you write it out with the plus and the minus, or this number here in front, that's called the expanding piece. And on the left-hand side, that's the condensing piece. So we can go back and forth using these properties, depending on what our numbers are and what we're trying to accomplish. So this first one, if I'm taking the log base b of a product where I'm multiplying two things together, I can separate it with addition using the same base in your log. So log base b of m plus log base b of n. So looking at that with some numbers, if I have the log, in this case it's base 10 of 5 times 8, I can do log of 5 plus log of 8. It'll give me the exact same answer. One of the advantages to this is if you can calculate one but not the other, you can separate it out and do the calculation. Don't forget we have the change of base formula, so that could help us solve. So if this was like log base 3 of 8, I could figure out what it's actually equal to by doing log 8 divided by log 3. So lots of advantages to expanding or condensing this kind of an expression. Now we're going to look at the divide. If you do log base b of a division problem, m divided by n, you can expand it using subtraction. So log base b of m minus log base b of n. So looking at it with some numbers, if I have log base 3 of 7 divided by 4, that equals log base 3 of 7 minus log base 3 of 4. The top number always goes first and the bottom number always goes second. It is very important to keep them in the right order because we are subtracting here. So then we could use our change of base if we wanted to figure out what these were actually equal to and do log 7 divided log 3, log 4 divided by log 3, and then subtract those results. We'll be doing that kind of thing later. Right now, we're just expanding and condensing our expressions. Then we have a power property. So log base b of m raised to the n power. You can actually bring this power down to the front, and then it's n log base m, or I'm sorry, log base b of m. So with numbers, log base 5 of 7 to the third power, you can bring the 3 down to the front, and it's 3 times log base 5 of 7. Again, these properties allow us to do some simplifying when we are trying to solve equations, and it allows us to isolate our variables as we're solving. And so we'll see some of that later on when we get to standard 20. So there is an assignment that goes along with this. All you're doing in the assignment is changing things back and forth using the change of base formula and just rewriting it. That's all. You're not actually calculating it yet. And you'll be doing some of these expansions and condensing of log expressions. So expanding has the plus, minus, and times the exponent. The condensing is putting it back together into just one single log expression. If you have any questions, please let me know.